Hi there, you're in the lab with your mate JJ. Today is Maxitronix 30in1 day. We're going to do a project from our Maxitronix 30in1. Today's silly job title is Grounding Genius. Today I'm the Grounding Genius. Of course, our Maxitronix 30in1 project is what we're up to. We'll be working through project number 8 today. This will be the last Maxitronix project for the year. After we've finished recording this, we're going to start working through our Maker Advent calendar. We'll be doing one project every day leading up to Christmas. We're actually going to go a little bit ahead of Christmas. We'll be finished well and truly by Christmas time. So this is from thepiehut.com. It's called the Maker Advent calendar. It's the one that they're selling at 2025. So I purchased this recently. I thought it might be a good change of pace over the Christmas period to do this. We'll be starting on that, I think, tomorrow. So if you're interested in the Maker Advent calendar and what that's all about, come back tomorrow and we'll be doing the first project. And then we'll be doing all of the other projects until it's done. But we're not doing that today. Today, we're going to be working on our Maxitronix 30in1. So we'll pop over to the computer and have a look at what's going to be involved. Then we'll jump over to the booth and we'll assemble the project. Once that's done, we'll pop over to the bench and we'll have a look at how the circuit behaves. So first things first, let's read about the circuit.
All right, well, here we are on the computer, and we're just going to have a look at the notes for project number 8. Project number 8 is the slow motion sunrise sunset. Circuit number 7 was the non-slow motion sunrise sunset. So we've already done a version of this. Looks like now it's going to slow down a little bit. We're probably introducing a resistor, are we? Also maybe a larger capacitor. I don't know, we'll see. So in this circuit, the light from the LED comes on extremely slowly. Complete the wiring and hold the long wire to 33. Okay, that's joining this to this. In about 20 to 30 seconds, the LED will begin to light up. Remove the long wire and the LED will slowly go off. It may take 5 minutes or so. As in the previous circuit, the LED will go off quickly if you touch the long wire to 41. It says 41 over here. This circuit works much like the previous one. The LED comes on more slowly because of the increased resistance in the input and because both transistors must be switched on before the LED connected to the output can light up. So this is the circuit. I might just out of curiosity just check out the previous circuit. So let's compare. So this project was the original Sunrise Sunset, circuit number 7, and this is what it looked like. So here we've got what they call a Darlington pair. I believe that's called a Darlington pair. But the capacitor is the same. The resistor is bigger. So the capacitor is the same. The resistor is bigger. And this 680 ohm, that's still in series with the LED, but there's also this extra transistor in here now with a 10K resistor. I don't know if you call that a pull-up resistor. I think maybe you do. So there's this transistor and then the same transistor again. We're using 2 NPN transistors here. Yes, that's what we'll be building today. So having shown you the schematics, let's make the circuit in KiCad. So start KiCad down here. Just be a sec. All right, so this is project number 7 that we've got open here. So we're going to have a new project, and we're going to call it project number 8. I'll put it in here. Yeah. Cool. So let's open the schematic. All right. Now this is the circuit that we'll be drawing up. Add in some resistors. So we're going to have 1, 2, 3, and we're going to add in an LED. Oh, yes, okay, LED, which doesn't have a it doesn't have a spice model, but that doesn't matter because we won't be doing a spice model for this because there's no oscillator and the switch is too hard to do at the moment. I'll figure out how to do it one day, but not today. Just 1 second, I'll be back. I just had to bring up my cheat sheet. You can't see it, but I can. So if I press this, that should rotate. Good. Now we're going to add VDC. So we'll add 3 volts voltage source. We're going to need to add 2 NPN transistors. NPN. And put one there and one there. And we're going to need a polarized capacitor. We can do that. Cap. Or just C. C polarized. Wonderful. I'll just put that there. All right. So, just zoom everything in. And what have we got? This guy. $470K. And this guy, 10K. This guy is 680. And the voltage is 3 volts. All right. So let's wire. This I have to put this in. This is 100 microfarads. that's our circuit. So if we were going to be doing the modeling, we'd have to go in here and click simulation model and change the model to be a diode. And I can never figure out how to adjust the forward voltage for the diode. It'd be good if we could do that, but I've never been able to figure out which setting that would be. As forward knee current, but doesn't talk about a forward voltage. Forward bias. Yeah, there's some forward bias stuff, but it doesn't seem to just be straight up forward voltage. So I don't know. Anyway, that's everything. We're not going to be doing the SPICE simulation, so we've just done the schematic. I think we got it all right. We got the capacitor in here. We've got the 2 diodes in. We've got the 3 resistors in. Got an LED power source, and there's the terminals here for the switch. So let's go over to the booth and put this thing together.
All right, well, here we are in the booth. The first thing to do is take out the old wires, so let's do that first. All right, so that's all the old wires out. Now the next thing to do is put the new wires in, so they're just following the instructions up the back there. All right, well, that's all the wires in, so let's take this over to the bench and have a look at it. All right, so here we are on the bench. Now, it did say that it'll come on slowly, so what we're supposed to do is connect this wire from pin 40 across to pin 33 in order to start charging the circuit. So that's here. Let's plug him in. Let's just wire it right in there. Now, we want to keep our eye on the LED, and it should slowly light up after some time. I think we're going to get impatient with this. Yes, it is taking a very long time to warm up. So let's change the parameters a bit. This is 470K. Let's pop it down to 100K and see if things charge sufficiently quickly for us. If we do that, yes, it charged very quickly, didn't it? And then we take it away, and it'll discharge slowly. And if we want to discharge it very quickly, we touch that there. Okay, so let's again show the charge time. 1, 2, 3, 4, 5. So about a couple of seconds to charge up, and then we'll take it away. And this capacitor will keep the first transistor switched on for a very, very long time. And eventually it'll run out of juice and the second transistor will be switched off, but it's going to keep it on there. And of course, if we want to hurry things along, we just short out the pins on the capacitor and bang, it's got no more power to power the transistor. Now, is there anything particularly that you'd like to see in terms of current or volts or anything like that? We do happen to have the 01 meter up the back there, so we could probe around. Maybe I'll get some alligator clips and plug them in on the welcome cam here. I'll just flip that over there. You can see up the back here we've got common and input. So if we wanted to, we could take a voltage reading. Let's do a voltage across the LEDs. So see what happens if we take a reading there. Should be 0. That's very close to 0. It's 0.49. That's actually a little bit of juice going through there. All right, now let's charge him up, and it should be 1, 2, 3, 4, 5. There he goes. So the forward voltage across the LED is 1.8 volts. And if we take that away, we're probably going to see it go down. Yeah, there it goes. It's starting to come off just a little bit.
and eventually it'll run out of juice. I don't know if we can do a voltage measurement across the capacitor without affecting the capacitor too much. Yeah, it's not draining the current too much. So we're looking at about 1.2 volts across the capacitor, which is enough to keep the first transistor engaged. In fact, when that comes down to, I guess, about 0.6 volts, that'll be when that first transistor stops conducting. I can throw you over to the thermal cam, and we can have a look at the thermal properties of this circuit. What have we got? We've got, I think that's the, oh, that's the switch there. Okay, so we need to put it in view. Bring it across there. Can you see it? Not quite. All right, so what are we looking at? The LED is here. So not really seeing much power get chewed up by this thing, just some reflections from the spring terminals. It's not chewing a lot of juice. You wouldn't expect anything to get particularly hot. So let's throw it back over here. Or I think we had the that one there with the voltmeter. So you can see that voltage is continuing to fall back across the capacitor here. I reckon when that hits about 0.6, it'll be completely off on the LED. Is there anything else to show you? Not really. This will be drawing some amount of current. Won't be much current. I suppose we could put our meter. I'll just I'll flip you over to there. And up here we should be able to put our thing in current mode. There we go. Put him on current. I was expecting that to change. Say input, output. Why didn't that work? I don't know. We'll take this guy off, and we'll just 1 second. I'll be back in a sec. Okay, so the problem I was having there is that it seems when the software's hooked up to the thingammy here, the interface buttons stop working. You have to control it through the software. So I've done that now. We're doing a DC power. So I'll just intercept the power up the top here, and there's no power being drawn, and we'll just hook up our power switch, and should be 5 seconds, and there it goes. So I'm not sure why we're not seeing. Oh, there we go. It's figured itself out. So it's is that microamps? It is. So it's 1.64 microamps, and if we remove the thing, the power doesn't change a whole lot. Oh, it's starting to fall off pretty quickly, actually. Oh, that's interesting. So the power is slowly drawing away, and if we just short out the capacitor, it goes all the way down to 0 volts. Fair enough. Is there anything else to show you? What have we done? We got voltage and current readings. We had a look at the voltages and currents with the voltmeter. We looked at the thermals. Is there anything on the oscilloscope to show you? Not really. There's no real oscillator or anything in this circuit, so we won't throw it over to the oscilloscope. In fact, I think we'll wrap up. That's everything.
And that's a wrap. So that's the end of project number 8 of our 30in1 Maxitronix. This was the slow motion sunrise sunset light. We didn't have enough patience to stick around with the 470k resistor, so we knocked it back to 100k so that things charged up and discharged a little bit quicker for the timescales that we were working with. And we learned a little bit about the Darlington pair. The first transistor controlled the second transistor controlled the LED. It was the 10 microfarad capacitor that kept the charge on the first transistor to keep it on for such a long time. Yes, and that's everything that there is to learn from this circuit. So we will continue with the Maxitronix 30in1 next year. We'll pick it all up again. And as I mentioned, we'll be doing the Maker Advent Calendar coming up in the tail end of December, I think starting tomorrow, which is Friday. So that's the end of this video. I hope you enjoyed this video. Thanks very much for watching, and please remember to hit like and subscribe.